Right, I think we're on the air, so this is a follow-up to the previous Xonar DX repair stream. I'm gonna make this quick because I think I've figured out the issue off camera, and that would be I took, this is the actual ADC of the card, and I just took it off, and it no longer seems to be shorting out in some of the modes. So I'm just gonna put this op amp back and try and fire off the card with the op amp installed, and we'll see if it works with the op amp, and if there's no longer a short with the op amp installed and everything in place, then I'm just gonna rule bad chip, because that seems to be a likely scenario. Notice me, senpai. I'm noticing you. Hello, nah. But yeah, let's just get this thing put back together, tested, properly diagnosed. What happened to the microscope view? Nothing's happened to the microscope view. It's right there. I can even see it on the stream feedback. There you go. Now it's clean. Yeah. I think this card is going to need a new CS5361 ADC chip in order to work. I'm not sure if I can be bothered ordering one. Probably. It's probably not a super expensive chip. Sadly, I had a bit of a dig around among my sound cards, and I couldn't find any of these just lying around, so I don't have any card to just rip this off of, which is a shame. It's not a very common part since it's such a relatively high-end ADC. There we go. Op amp back in place. Just got to put the ugly ceramic capacitor back in. And if you're just joining the stream and you didn't watch yesterday's stream, you're sadly out of the loop. But basically this sound card's fucked, and I ruined a bunch of shit on it yesterday. And hopefully we're not ruining anything more today. But I don't think we're going to be fixing it, just giving it a useful diagnosis. And I'll have to think about ordering parts to get it properly up and running again. Oh, come on. That's good enough. That is good enough. Round 2. I love this guy. I'm glad to be loved. I need love. Can you show us again? Show you what again? Yeah, I think this is good to go. And that's where the ADC used to be. So this card is not going to be doing any ADC conversions whatsoever right now. None at all. But we will figure out if it's shorted. And yeah, we got to kind of a hard drive for a Windows. So I want to see if the card is actually starting up and booting and doing shit even though the ADC is not installed. I think it's a pretty stupid ADC that wouldn't lock up the firmware, but you never know. It's one of those firmware-y, computer-y things which has a mind of its own. Well, that's just to confirm that we no longer have a short, the computer's turned on. Oh no. Huh. Fucking hell. It's shorting out now. Ah, it's shorting out. Okay, so this is not the ADC, which I suppose is good. It's good that it's not the ADC. But that just makes everything more confusing. It's not the ADC, so what is shorting out? I've printed out some schematics for the input buffer and stuff out of the datasheet for the ADC. And everything checks out. It's pretty much a reference design as far as the filtering goes, but we just have an extra buffer stage. We have an extra buffer stage before the filter circuit for filtering out high frequency stuff, and it's just the buffer stage we're working with. What's an annoying turn of events? I was so confident that this was just going to be the ADC being weird. But clearly that's not the case. So there's some other faults. Hey FF, what did I miss? Nothing really. I soldered an op-amp back in. And the card is not working still. That's annoying. I was really hoping we'd just get some resolve. Hang on. CS4398. Oh yeah, that's a DAC. That's a DAC. That's got nothing to do with this. Yeah, we're back to square one. Damn it. I was just gonna hook this up, confirm that the ADC's fucked. But that's clearly not the case. So what's fucked? It's difficult to go about this in any kind of objective fashion, since we can't bloody well see anything due to the bloody dark PCB, and it is a mess full of flux and crap. But well, that's not the worst issue. We can't even see anything on the clean part. Well, there we can see something. Well, that's not a nicely soldered cap. Generally, the soldering quality on this board is not great. They've been a bit short on solder in some places. How annoying. Well, this is not much of a show. I need to think about this. How embarrassing. What would cause an op-amp to short... Let's check. Let's see. Do the op-amps get any power if we just connect up the auxiliary power connector? Do the op-amps get any power? I'll just fire off a PSU with a hard drive and have a bit of a mess around. Oh shit. Don't want to have SMD parts lying around out of a bag. That's gonna screw you over. Yeah, if you just joined, this is not gonna be a very entertaining stream, I don't think. Because I just need to sit here and think about what's going on. And I'm bitter about this card not working properly. Do we have op-amp power supply? Something on the other side of the PCB. I have no idea. This card board is generally really difficult to skate around, since you can't see anything, and the other side of the board is just chock full of giant surface mount capacitors, and everything's going underneath them, and I'd have to pretty much disassemble the entire board in order to see and measure anything. And we're out to get the op-amp power supply. Do we have op-amp power supply? Yes. We have op-amp power supply. And the op-amp power supply is plus minus 8 volts. But let's verify that I didn't make a mistake yesterday. So if I just connect up signal, no, it's not entirely shorted. But is it the same on both channels? Yeah. It's the same on both channels, just kind of loading down the output. Okay, let's be no about it. Let's scope around. Since we are powering the op-amps in this stage, we can at least have a bit of a look at the signal. But sadly, I think the signals are going to look absolutely perfect. I think everything's going to check out just fine. I have lost my scope probes. Let's see. I want to bet that everything's just going to look absolutely peachy and fine and perfect. Since we're not having the actual issue unless the PCIe is plugged in as well. Which leads you to suspect a chip like the ADC, since that could be powered from PCIe rather than the analog supply. What's going on? We are continuously getting fucked over by this card. It didn't have the issue I initially thought it had. Well, start of a stream, so now we're just basically meshing around randomly again. Let's just verify that we can see our signal. That's an incredibly distorted sine wave. Wow. It really doesn't like input signals over 100 millivolts. So it is still loading down the output a lot. You can't properly see the scope. And if this thing can handle input signals of about 2 volts RMS, but we can't get over about 400 millivolts RMS. About 600 millivolts. Let's measure it. 600 millivolts peak each half cycle. So that's about a diode drop. As if we've got something conducting to an ESD protection diode somewhere. Let's swap to the other channel, see if it behaves the same. We still have a low signal level, but is it still distorting? Yeah, it's still distorting the signal. It's distorting the signal massively. Oh yeah, you can even see it on the webcam. Your mic is acting strange. When you speak there's a lot of noise. When you're silent there is much less noise. That's because I'm noise gating it because it's so noisy. Waves of noise in the audio. Yes, that is intentional. I've got a VST host running a noise gate on the mic. Has to be muting or protection diode somewhere else on the board. Yeah, that seems to make sense. But it works fine if this op-amp is not installed. How's everything look on the input of the op-amp? In fact, let's feed the stereo signal so we can monitor both channels at once. And that will give us a clue as to the nature of the issue as well, because if the signal drops further when we connect to the other channel, that suggests a resistive load, whereas if it just basically stays at the same level, that kind of hints at some kind of diode voltage related thing. But I have lost my RCA splitter. Oh, there it is. This sound card. Right, both channels are both making a connection. Let's just probe that. Signal there. Signal there. And we're still seeing about half a volt RMS. 600 millivolts peak. So it's looking very identical. Very identical on both channels. Now that, in this stage, that could be due to the fact that a lot of the circuitry is unpowered. So the op-amp could be trying to drive something which is just ESD protection shorting, since there's more voltage on the input than on the output, than on the power supply. So that's a bit of a bummer. It's just looking identical anyway. There's one input, and I think we should have about the same signal on this input. That one. Ah, God. Okay, there's nothing on there. That's weird. We've got input on both op-amps. Do we have... What's our output look like? What does our output look like on that channel? Identical. And it's going to be the same over here. Yep. So the op-amps are doing exactly what they're supposed to do. They're putting out, acting as the unity gain buffers they're supposed to be. I got some needle point test leads a month ago. You should try them. A bad connection, world will change. Well, I have needle point probes. These are very needle pointy. Although my scope probe's a piece of shit. This is not a good probe. It's the cheapest one. Yeah, I don't think we're going to get anywhere without PCIe power connected, since we're just pushing signal into some ESD protection somewhere. Granted, it is a bit weird that we would be hitting ESD protection, since we should be feeding into... where are we? We should be feeding into this chip which isn't populated, and we should indeed have... We should be having signal on these caps. We should be having signal on those caps, but we don't. Because these just go straight to the input filter. Do we have all op-amps powered, or just these? That's worth checking out. Do we have power on the filter op-amps? Let's verify. Yes. Do we have power on that one? Yeah, we seem to have all pumps powered. What we have out our regs. This is a 7805, which is not putting out anything useful. Is it just, is that the thing that's syncing our input signal? No? That's just going straight to 0 volts. What is a Xonar? It's a mid-end sound card. We could just power that 7805 up. Yeah, that would be very easy to do. It would... perhaps that's what's powering most of the other stuff, actually. It would make sense for them to use linear regulation for it, so let's just power up our 7805. I'll just put a little lead on it, and we'll give it some power. Or rather, we will put 5 volts on the output. Soldable there. Let's do you guys a service and zoom this thing out since we're not doing microscopy stuff. There you go. Actually have a chance at seeing what I'm doing. And wire goes to the output of our 7805. There we go. For ground, just that piece of air, so it doesn't quite matter where we ground it. So we'll do 5 volts. Let's do 600 milliamps. The card does seem to draw a fair amount of current on the 5 volts since that reg is running so hot. Ground. Power. We probably want to turn these on and roughly at the same time, but we're not going to be able to, so let's just plug that in and turn that on. It's drawing 300 milliamps. And yeah, that caused our input signal to get entirely shorted to ground. Sweet. So we are replicating these symptoms with a card out of a computer. That's excellent. Now we just need to figure out why turning the power onto the card is causing the input to get shorted. Because I'm still entirely stumped as to what would be causing that. Entirely stumped. 42 people watching. That's nice. Alright. Let's fix that for you. So what's the 8-bit of our op-amp look like? Let's probe. That's there. Oh god. This is extremely noisy and horrible. That's not a nice sine wave at all. But then again, we are. Yeah. It's just weirdly loading everything down. This is such an odd issue. Because I have no idea where the signal's actually running off to. I have no idea what would be shorting it out, but at least we have some kind of signal we can trace. See where it's actually going. Ouch! Jesus Christ! Our DAC is running bloody hot. That almost has to be a fault condition. It's weird if our DAC would be causing issues with our ADC, but that's running so hot. 60 degrees. Over 60 degrees. 65. Jeez. That's a hot bugger. Huh. 64 degrees at its hottest. But that is weird. That is weird. A thermal cam would be an excellent idea. Hey, you're free to send me a thermal cam if you want to. I can't afford one. Yeah, we're gonna have to check the datasheet for the CS4362. Because I'm not sure what the power dissipation of that chip's supposed to be. It could be supposed to be running this hot, but I doubt it. CS4362. I mean, that's probably where most of our 300 milliamps on the 5-volt rail is going. Hello, greetings from Poland. Hello, Poland. Right, datasheet. What's it say? What's our power dissipation? How hot is a CS4362 supposed to run? Power and thermal. Normal operation, 55 milliamps. Power dissipation, 400 milliwatts. Okay. So, 400. This could be 400 milliwatts. It could be 400 milliwatts. Still though. Jeez, it's running even hotter now. It's still heating up. $65. That's like almost 70 degrees. package thermal resistance 48C per watt. So we would expect a 48C increase at 1 watt, and we're seeing pretty much a 50-degree increase when you're just sitting around. How hot are we? So we're 22. So that gives us 68 minus 22C. That's 46 degrees. Now that sounds a bit hot. Now that sounds hotter than I would say is normal for something like this. It doesn't. It just strikes me as weird. A junction to air resistance is 48C per watt. So, am I entirely incorrect in saying that in order for this thing to be rising 46 degrees, we have to be dissipating almost a watt in it? I mean, surely that's not correct. Surely that's not correct. So the question is, what's causing that? Now, 8-bit op amps are also running somewhat hot. They're not super hot, but they're warm. Like 36 degrees, 37, almost 40. Don't think our input op amps are running even hotter. But they're short at 8 and trying to push signal, so I suppose that's justified. Oh my god, I thought it was a vid. No, you're live. Hello. I wonder. We've got a CS4382 sitting on this card. Sadly, it doesn't have the matching ADC, but the ADC seems to be fine. We could just swap chips between these, but I'm wondering if there's some weirdness that would be causing it to behave like that. If there's like something causing an op amp leaking its supply voltage into a data pin on the chip, and it's like getting 8 volts somewhere, or minus 8 volts. Where's the pinout on this thing? Give me a pinout, please. Cirrus Logic are shit at their pinouts. They just put them at some random spot in the datasheet. Package dimensions. Please, all I desire is to see which pin does what. Ah, there we go. That's a pin 8, so we could just probe around and see if that's just something causing a super high voltage to be pushed into this chip from somewhere. We've got a VA there. Oh, we've got to go back to a microscope. Whoosh. Let's see. Where's our chip? Let's just grab ground from somewhere. Let's use the red and yellow lead for ground. That's great. And it's not at all confusing. There we go. So we've got all the 8 bits basically along this side. Let's just measure those and see if something's causing 2 volts. Something's causing that to be excessive voltage on those. Oh, there I shorted something out and now it's doing different stuff. Did I just break something? I might have just broken something. Let's reset everything. It went tick and then started drawing less current. Now it's back to drawing a lot of current. Oh no, it's drawing slightly less current. Oh, the chip is still bleeding hot. I might have shorted the analog input voltage to one of the outputs. So that would probably engage an ESD protection diode. Or I could have shorted the analog input to ground. Oh well. It's good enough. So pin 5 would be the input voltage. 1, 2, 3, 4, 5. That's... oh god, non-stereo. This is extremely difficult. Yeah, that's 5 volts from the 7805. That should be ground. That's ground. And these are all our outputs. 5 volts. 5 volts on that output. That looks wrong. Well, differentially. I mean, this output just looks slammed into a rail. 4 volts. This is looking weird. I wouldn't be expecting I would expect all these output to sit at half supply voltage, like that one. That's what I would expect, because that's one positive output. Now that's negative output. That's positive output. This is looking weird. This is looking weird. Let's see what the allowable ranges for these pins are. This is the wrong laptop to be reading datasheets on. 1280 by 800 isn't enough. Analog characteristics. Full scale differential 8-bit voltage. 88% VA. VPP. Quiescent voltage 50% VA. So it should just be sitting at 0 volts, at half supply voltage. It should not be sitting at random voltages between 0 and 5. So I would be willing to wager that something's causing this chip to screw up. Either something's like something, one of the op-amps on the 8-bit is fucked, or the chip itself is fucked. Absolute maximum ratings. And we do not get any data for allowable voltages on the 8-bits, which makes sense since they're supposed to be generated by the chip itself. Maximum is specified to 94% of VA. So let's just... What's our input voltage? I don't remember these pins now. Is that our input? 4.92. And that should be ground. That's ground. .85. How many percent is that? 4.85 divided by 4.92. That's 98% of the 8-bit voltage, so that is outside of the allowable range for that pin. Do we have any other power supplies we need to be concerned with? I mean, this is looking fucked. Which is weird because I think this has worked fine. Granted, I've only ever tried the front analog outputs, and those are provided by that chip over there. Because that DAC does the front channels, this DAC does the rest. Let's see, where's my pin 8? Let's find the random... There we go. Random spots in the data sheet with a pin 8. Instead of having it in the front like everyone else. You've got VD and pin 4, which is probably 5 volts. Let's check VD. One, two, three, 4. That's nothing. Okay. So we have no digital supply. I wouldn't expect that to be affecting the analog supply. I mean, you'd figure those are separate. But why would it not have a supply? I would figure that most of the power supply would be derived from the 7805. This is just getting more and more confusing. Oh, there's a random transistor package. The digital supply could be derived straight from... directly from the 5 volts coming out of the PCIe. I'm not just... Is there 5 volts coming out of the PCIe? I don't know. That probably is. Well, that sounds very computery. So it could be something like that. But you wouldn't... No. Lacking a digital supply voltage, I don't... Ouch. I should stop touching that. Let's just take this thing off and see... And put the ADC back and see what it does. Let's do that. Let's consult the chat first. Try 12 volts on the input of the 7805 if it powers more stuff up. That's a reasonable point. But I don't think there are any more voltage regs. Oh, there could be more voltage regs, yeah. Let's go with a chat and see what we get. Well, let's scroll up and see. Scroll up and see. You are live on YouTube, please do not fucking swear. Cool it down with freeze spray. I don't have any freeze spray. Look at all the VREGs. Yeah. Looks like I made it to another stream. Yes, you did. Right, yeah, let's do 12 volts on the input of a 7805 gen, just in case. Because we do have this weird thing there. I'm not sure what it is. It could be another little digital VREG. I mean, whatever the number on the chip is specified for like tens of milliamps rather than hundreds of milliamps. So you would expect it to. Yeah. Let's unplug the power before we start soldering. That's a good idea. Unplugging the power first. And we'll just do that. Let's hope this is, yeah, this has to run off a 12 volt rail. There's no 7 or 8 volt or something in a PC. Let's do 12 volts to the same current limit. .0. Okay. What's it gonna say? Is it gonna go bang? Nope, it's just doing the same exact thing, shorting the analog input 8. Is drawing slightly less current, which is weird. So do we now have a digital supply on the DAC? Do we have a digital supply on pin 4 of a DAC? Or is that derived directly from some internal 5 volt rail of a PC? Zero. Absolute zero. Okay. I'm curious as to what this thing is. It looks like a tiny reg. Are you a tiny reg? Reveal your secrets. 0.6 volts. 0 volts. 0.6 volts. PSA 85P. What is that? PSA 85P. Psalm 85. Thank you, Bible, for ruining my search results. PDF. And free prostate-specific antigen US. Okay. So this card has a prostate issue. Yeah, there's a lot of prostate-specific antigens here. Prostate cancer in the elderly. another number in this. S700. S700. And that's some embedded Siemens product. Lovely. Well, this is going well. PSA 85p. I really want to know what that thing is. PSA 85p. Let's just do PSA 85. Religious behavior and experience. Hilti PSA 85. Well, let's do Google. DuckDuckGo has failed. Hilti. Oh, lovely. So this is the number of some power tool. PSA 85 SMD PDF. SMD NPN transistor. Missing PSA 85. Missing PSA 85. PSA 85%. PSA 85 psychiatric care. Delaminated Epstein-Barr virus nuclear antigen 1. This is going great. So Google is failing us as well. Oh, we even managed to get 0 hits. Not a single hit. Well, that's lovely. We have no idea what this component might be. Oh well. This thing is no longer feeling as if it's about to catch fire. It's just barely 56, almost 60 degrees. Is something drawing so much power that the output of a 7805 is sagging? Nope, that's doing well. This entire board is running so warm. Everything's running warm. Every single device. The entire PCB is like, well, it's like 35, 40 degrees no matter where you measure it. These are not very efficient cards. Has he found more dead parts? No, but we've eliminated one. Man, I want to take this thing off. Did that output just kind of swing randomly too? No, this is putting out too much voltage. This is putting out too much voltage. I don't trust the 4362. I don't trust it. We're gonna take the 4362 out and see what the computer does with the card. I am highly skeptical this is actually going to provide any useful data, but I'm curious. Why? The board is running so hot and the flux is melting by just going on the board. This flux, by the way, is SRA brand. SRA TF5000 from p2bsoldering.co.uk, if you're curious. Tacky flux. It's working very well. Very low odour. It doesn't smoke anywhere near as much as other solders of this type I've tried. Do you have a PCIe riser? No. I do not. It's really annoying. I should have, like, a super long PCIe extension cord for testing this, but I so rarely work on PCIe cards, it doesn't make any sense. Oh yeah, let's get rid of that annoying crap. There we go. That's better. Why is this not coming off? Why is that not coming off? That's annoying. There we go. Smoky. We're getting a nice collection of components coming off this board. That's going to take forever to cool down. Oh, I forgot to disconnect the signal while I was doing that. Whoops. Cool down, please. Have I fucked up some tracks there on the ADC? Oh no, it's just... For a moment, when I was looking at it, it looked as if these guys were fucked up and lifted, but it's just solder. Thankfully. Oh, that guy's doing okay. In fact, we don't need to put this in the PC to test. I shouldn't have disconnected all this stuff. You can just power it on like this again. And we will find out if it makes a difference. There's my power connector. It's cool enough by now. Yeah, cool enough. Power 1, power 2, and it's using a lot less current, but we still have issue. We still have issue. It's drawing 50 milliamps rather than 200. How much current do you need at 5 volts for the 4362 to actually live up to its maximum power consumption? That's like 0.4 times 5. No, that's wrong. It's not gonna. It's not going to need 2 amps. Let's just cheat. Scale voltage 5. Power 400 M. So maximum current the 4362 is allowed to draw is 80 milliamps. Let's be generous. Let's do 800 milliwatts. And that's 160. So even at double its rated power, this chip was not doing what it was supposed to be doing. Now I'm curious. Do we still have a weird voltages on the output pins of that? Because I would expect those to be just nothing now. 0. Or oscillating, not properly connected op-amps just giving random waveforms at hundreds of megahertz. Minus 700 millivolts. Minus 0.8. Minus 0.8. Minus 0.8. That's power 5. Ground 0. Minus 0.8. Minus 0.9. Minus 0.8. Minus 0.9. Minus 1.3. Minus 1.3. Why are we getting negative voltages there? I would not expect there to be negative voltages there. Check switching MOSFETs. What switching MOSFETs are you referring to? This sound card switches the input signal using relays, if that's what you're thinking. Now we could just put the CS4382 from the creative card in there instead. They're supposed to be pin compatible, I think. That S700 is TLV6256. Okay, let's Google that and see what it is, because I'm curious. Let's see how correct you are, chat. TLV6256. All data sheets. 1.5 amp high efficiency step down converters in SOT23. That sounds plausible and does sit right by the big choke. Give me data sheets. 2.7 to 5.5 volt input, yeah, sounds about right. V in, that pin. Okay. Does this voltage converter do what it's supposed to do? So that's our input. 0.6. I wonder where that's going off to. if it's powered by the 7805 or if it's getting power from somewhere else. Let's beep it. It's really annoying just grabbing at straws like this. I hate this kind of troubleshooting because there's no good objective way to troubleshoot this since we have such a poor insight in how the board works. That's not going straight to the 7805. That is a big choke. Does this go straight to the PCIe connector? Yes. Okay. So those are going to be 5-volt pins for the PCIe. Let's put it in the computer without the 4362 and see what it does. If it behaves differently, because we do have, we are missing a supply since that regulator is running straight off of the pay supply coming out of the computer. So let's try that. So now we have no DAC and no ADC. This is a rather useless sound card at this stage. I suppose you can still put out SPDIF. There's my power. We have a very big, very expensive SPDIF output. Power goes on. Let's hope this computer hasn't done the stupid thing it does where it sometimes randomly puts PXE as the first boot option and doesn't boot properly. Yes, it has. Lovely. I don't know why it does this, you can't even see it. It just randomly puts PXE as number 1. Ah yeah, it probably defaults to that if it's misdetected a hard drive at some stage. Let's see, can we exclude... How do we exclude PXE? Oh, that's the... F and R X exclude. There we go. Only hard drive. Okay. Computer fixed. What's for chat say? Oh yes. No startup repair, please. Let's measure that little chip and see if we're right about. I mean, it does seem plausible for it to be that kind of converter, since it is connected straight to what I'm assuming to be the 5-volt input. Granted, it could also just be ground. No, it can't, because it was reading non-serial voltage there. DC volts. Input 3.3 volts. So it is receiving an input, and it's likely that chip. It seems plausible, but now it's actually powered on, and we still have the shorted input. How annoying. How annoying. What the hell is there left to remove? I mean, I want to believe that it's just some random shorted ceramic cap or something, but that doesn't explain why it's only doing this with the voltage applied. We could still try it with only voltage on the 7805. Back in a sec. Alright. Alright. Let's try it with only the 7805 powered, see if that does anything. We are not shorted now, power on, and we are shorted. So, turning the 8-bit of a 7805 on causes something to go low impedance. But we don't, we don't even have any supply for the op-amps connected. That's the annoying part. It's as if there's a shorted cap between the input and the 5 volts. So we could just probe around, try and spot 5 volt caps with 5 volts on one side and signal on the other. Because that just in my mind it works. A shorted cap between the input and the 5 volt analog rail coming out of that 7805. It's just probing. Endless probing. If we disconnect this, do we get a giant DC offset on the input? We don't get to... It's a good idea to connect your fucking meter before you try and make measurements. Come on, there we go. That's better. Do we get a giant DC offset here? No. If there was a shorted cap between the 5 volt and the input, you would expect to see a giant DC offset on the input. Or 5 volts on that pin, but this is a combined optical output as well, so that's probably for that. Our analog inputs are these guys. That one. And that one. And neither of those have a giant DC offset where they're sitting flat at 0 volts. No, but the 5 volt is low impedance to ground too, so it would be AC shorted without power anyway. So it's not a captive power rail or ground. Yeah. Well, I'm figuring the 5 volt would be high impedance basically to ground if it's not powered on. I mean, it would just be floating. You'd have a capacitance there basically. But no, yeah, I suppose you would be trying to put AC across like a big electrolytic cap on there, so it makes sense. So then the question remains, what on earth is causing it? It's just so confusing. are so many parts on this board. Let's have power supply gone. What are these guys doing? 12 volts. Nothing. Nothing. These are switching something. Are you shorted? Let's turn the power off and see if that's shorted. It's sitting quite far away from everything, so I doubt that's the issue. But hey, it could, depending on the polarity of this transistor, it could be failed. No, that's not shorted. I'd wager that's a healthy little transistor. Let's see if we get a diode drop one way. .18 volts. Oh, there we go. Diode drop that way, 0.6 volts. Yeah, that's good enough for me. What about those 6-pin packages right by the input jacks? Are you referring to these on the other side? I think we figured out they were transistors. But they are by the 8-pin jacks, not the input jacks. They're labelled O2NH. We've got 1, 2, 3, 4, 5, 6 of those. And they're sitting by the 8-bit connectors. I would be kind of curious to just... I know there's no point removing the relay, because we know that if we engage the relay, the issue goes away. So it's something after the relay. These things are just relay switching, protection diode and switching transistor. $78.08, that's provided with positive op-amp supply. There's some boost converter. Now that stuff's obviously working okay. I'm not sure what that chip is. I have known at some stage. It's one of those... It's a Cirrus Logic something or the other. Whatever that is, it's never been soldered in. Have you checked those electrolytic capacitors? I've checked some of them for shorts. The big heap we have in the corner here, these are probably 8-bit coupling caps. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's not a lot of them. That would be 2 per channel for 6 channels. Yeah, those are going to be 8-bit coupling caps from the 4362. I would be curious to put the 4382 in there instead of the 4362 because that one's acting so weird. But I don't think that would solve our issue. Let's just probe around randomly, try and find places where we've got 5 volts. Anything with 5 volts on it could be a culprit. Forgot my cables again. Lovely. I'm doing well. There we go. So that's got weird stuff there. .6 volts. Nothing straight to 5 volts. This is kind of far away from the 5 volt reg as well. So I don't think we're gonna find anything. I do not think we are looking at the right place right now. Nope. There's a cap with 5 volts on it. Where are you? Where are you? There we go. Oh, is there anything snaking off? No, that's just going a million vias to the other side of the board. Lovely. Like a very 6-pin MOSFET if one of them is short in the signal. Fair enough. I wouldn't try anything, but I think these are on the 8-bits. They are placed in a way which would suggest they are on the 8-bit, but it's worth it. It's worth a shot. You are right, Mr. Jonah Jacob. We will check them out. We'll just put some signal in. And turn the power on. Watch the signal get shorted out. Bam. This is one of those obvious things here. But it's weird since it's okay when the relay is disengaged. I want to be probing with a scope. Nothing there. Nothing there. Nothing there. Let's see how the signal looks on the scope right now, so we've got a reference. If it's even set up properly. Wow. That's looking way cleaner than before, but yeah, we've got 44 millivolts, so we can see it. We can see it. I think this board needs truck battery treatment. Well, it still works as a microphone ADC and as a DAC, so it's absolutely useful still. It's just that the one feature I actually want out of it doesn't work. There's something there. I think I measured these at some stage, and I figured out if they weren't dead shorted. And the placement, yeah, it just doesn't make sense to go on measuring these, I think, because the placement is by the 8-bit connectors. And for once we can actually see some traces going to the 8-bit connectors. So these are like muting or... or 8-bit protection. Focus. Weird that there wouldn't be any similar devices on the 8-bit phone, on the input. That's a bit weird. I'll probably shorted out the 5 volt there for a second. The signal spiked up. Yeah. Oh no, I'm shorting something out too. Oh well. Dropping aground. Tried bypassing the relay contacts shorted with wires. The relay is engaged by default. The relay is engaged by default, so the issue is not for relay. Like, we get this issue, the relay is not ticking when I apply power. I have to go to work. This is annoying. I really wanted to finish the video. We will not be finishing the video. I'm about to quit. Anyway, I'm getting tired of this. You just created a whisker. Yeah. I don't see any shorts. Maybe. Maybe. I will clean that. It looks like flux residue more than anything. Oh no, that actually is solder. There we go, cleaned. But yeah, those are 8-bit protection. Those are 8-bit protection. It is weird how the 4362 was clearly fucked though. That is weird. I think I'll just put the ADC back and use this as a microphone. ADC, I'm gonna give up now, for the time being. I'm not willing to put more brain power into this. I have other things to do. I have laptops to repair. A life to live. A basement to sit around in and post on 4chan. ADC. Where's the ADC go? ADC goes on there. There goes the ADC. Flux. This is I am annoyed by this issue though. I am so annoyed by this issue. Last night I was thinking about it in bed and I figured, oh yeah, it's gonna be the coupling caps between the ADC and the input stage. That's obviously it, because they're gonna be coupling to the power rails, but nope. Checked those out, wasn't the case. Hey, let's see if we can do a proper Rossmann here and clean these pads up with solder. We can put proper leaded solder on them. I'm so unused to actually having workable flux that I just never usually do that. Let's see if we can learn something from this. This is a relatively useless board anyway. That's clean. So let's see if we can do that thing where you just blob on a shit ton of solder on your tip and drag it around. Let the flux do its job. Let's see. I'm not good at doing this. That worked well. One bridge there. That's not bad. That's not bad. This is working excellently. Come on. I don't think we have any shorts there. That looks okay to me. Focus. That's looking alright. Let's be honest, what is the last thing that would fail? Well, the thing is, small ceramics, as I'm sure you're aware, like to go shorted if they're overvolted. And I think what's killed this board is me connecting a power amplifier up to it and putting like 15 volts AC on the input. With, you know, a lot of amps behind it. Oh, fucking hell. Seriously? Ugh. Someone says more flux, I agree. You can never have enough flux. I should get a cheap ultrasonic cleaner to clean shit up after I'm done with it. But I'm too poor. I need way more patrons in order to be able to do that. A sticky fucking chip. That looks right. Is that the right way around? Yes, you can see we've got the white line there signifying the way it's supposed to go. Is the solder already melting? No, it can't be. Ah, that's great. There we go. That could have gone worse. Yeah, that's fine. I'm happy with that. I'm a bit of a novice when it comes to soldering shit like this, so I'm happy with that. Let's just steal a CS. Let's just steal this chip right here, because it's the higher number version. So we'll upgrade the surround channels on this board slightly. Oh. The flux has attached the 40 whatever 62 to my bench very steadily. There we go. Do these look compatible? I would say those look compatible. Is it pin compatible? Yeah, they have the same pin 8 in the datasheet. They have the same datasheet as well, I think. Let's double check it. Fucking Adobe. Why does Control minus not zoom 8 in Adobe Reader? Well, it does that in every single other piece of software. What's the difference between the 62 and the 82? CS 4382. Let's Google that. CS 4382, complete 8 channel. Oh, is that the difference? If this is 6 channel, is that the only difference? Then it makes no sense. But the... yeah, that's the difference. Right, so yeah, these are actually not going to be... these are not going to be pin compatible, and there will be no point in it because the analog specs are the same. Let's see. Or maybe we just have like a few pins which are not used on the 62. Let's check that. Where's the pin 8? Zoom in. Scroll to the same place. Ah, yeah. These. What the hell did I now do? Fucking Adobe Reader. I need to install Foxit on this thing. Yeah. Yeah, chat is right. These are not pin compatible. These are not pin compatible. So, I'm pretty sure the one we removed is shot. I'm quite convinced this thing doesn't work since it's just putting out weird voltages. And it's running super hot, so we'll just ignore that and not install it at all. Because it's just drawing so much current, it's going to cause other issues. And I'm not prepared to try and figure out, like, put it in there just to test it. So we've got our ADC in there, we've got our awful bodged together repair there, which is not going to perform very well. And we've got the ADC, so let's pair this thing on, see if it works, and go from there. Maybe it just wanted the digital supply. Yeah, oh yeah, we never did try that. We never did try that. Alright, I'll put it in there. Yeah. I don't trust this chip. I really don't. No, we'll try with 8. If a card works with 8, we'll leave it 8, because it's just for the surround channels. I don't care about those. And it's a risk, and it's a bother taking it out again. So we'll just hook it up, do a quick performance test, see if a microphone input works and the 2-channel analog 8-bit works, then I don't care. Then we'll leave it. If it needs to like talk to it in order to initialize something, then we'll care. Power on. Power on, please. Oh, did I just... Power on, please. Alright. Why did you power off? Power on, please. Use an attenuated use for mic as a line-in. Well, the issue is that it's got a much higher noise floor on the microphone input due to some component, probably the input op amps, having much higher gain. So I'd have to like reverse engineer that and remedy it. And that would be too much of a bother. So I'm figuring if this works like this, I'll just put it in the streaming computer and use it as a mic preamplifier to replace the horrible piece of shit sound card you're listening to right now. We'll at least solve that noise issue, and I'll have a good high-end analog output on that computer, because the analog output on like these creative cards are just garbage. They are worthless garbage. They do not live up to the specs. They have noise floors which are as high as power amplifier noise floors. I'm surprised no one sued Creative about it. They're awful. Awful cards. Horrid. There we have our lovely input signal. Setting ADC device sound card microphone. It's now gonna go tick. Tick. And we are clipping a lot, and our input level is now fine. Oh look. Oh, you can't see that. Let's fix this. Give me a moment. We can do the fancy thing and use digital zoom on our cheap webcam. Oh, there we go. That's the input signal on the microphone input at a very low signal level. Like let's just turn it up a bit to... Oh yeah, no, it stops clipping. This is like 15 millivolts input. Oh, that could actually be way too little for this microphone. Actually, I could be just pushing it into clipping instantly. Let's just do Let's just measure some parameters, see that the performance is as it's supposed to be, processing measure, THD and so forth. Everything full scale will do. Can we even do ACO? I think we can do ACO. Yeah, we can do ACO. Is this right? Oh yeah. No, we can't do ACO because it's broken in this piece of software. MME. We need to adjust the settings for a recording device on Windows since we're running MME and Windows has to resample everything. Microphone, properties, levels 100%. No, microphone gain is on. Let's sample at 24-bit 192 kilohertz. Or we can't, because it won't let us set that 24-bit 48 kilohertz then. Format not supported, what? Okay, it's not letting us do anything other than 16-bit 44 kilohertz. Why am I not allowed to use anything other than 16-bit 44 kilohertz? Whilst the computer stopped. Oh, text relay, okay. Okay, now it works. The driver was probably confused, so let's do 2 channel 48 kilohertz, 24-bit. Okay. Now let's put the output to 48 kilohertz as well. 24-bit 48. Studio quality. Okay, yes, I know we're running non-genuine Windows. Right. And I forgot to save my settings. This is lovely. Measure everything. X scale, log, Y scale, dBFS. It did remember a line width setting. And stop this setting. Save as default. Let's do. Was everything stopped? What the hell is this computer doing? We want 48 kilohertz and we want to do sound card MME, yes, speakers Xonar DX, ADC device, microphone Xonar DX, excellent, that's right. 48 kilohertz, 24-bit, we want 48, that's the wrong keyboard. Give me 48,000 samples, 1 second of capture. And settings, save as default, record. Now your FFT, let's do 8192, this is going to run incredibly slowly. And scale it up. Okay. Now it's accepting a much higher input signal now. Let's see how heavy it can go. Okay, this is... Since, I turned the microphone boost off in the Windows control panel. This is looking a lot better. It's now accepting an input of almost 100 millivolts. Oh, that's clipping a lot. Okay, let's go a bit quicker while we adjust the level. Still the wrong keyboard. Alright. Let's see how high we can go before it starts clipping. Quite high. We're at like half a volt input now. That's not bad. It's useful. The levels are not matched though, which is weird. Oh, there we go, we're starting to clip at like just over half a volt. So let's step it down a bit, increase our samples captured and see how our performance is. THD 0.0019%, THD plus 9 0.0064. That's actually not bad. Noise level minus 92 dBFS. This is not bad at all, actually. This is useful. This is above all way better than the creative cards, which have like a noise floor of minus 60. So we're gaining like 40 decibels of dynamic range by changing from one of these pieces of shit to the Xonar. 40 fucking decibels. But yeah, this is looking fine. Let's do some high frequencies. Let's do 10 kilohertz. Pop. Still performing just fine. 13 hertz. How's that gonna look? It's performing okay. Same level, flat frequency response down to 13 hertz. That's acceptable, I guess. We can't measure any parameters. We don't have the FFT size for it. It's looking okay. So, yeah, as far as a microphone input's concerned, this card is still performing excellent. I mean, there's nothing wrong with this. Nothing at all. Half a volt of input. Excellent performance. "60 watches and 31 likes. Everyone should like this. Yes, you are traitors to the cause." Anyway, let's just test the 8-bit of the card as well. Which I'm gonna do with... What am I gonna use for that? We will use the bench stereo. So we'll just... which is the front panel output? Front. This is the only output which actually has a DAC. We'll just zoom out a bit for you guys. In fact, we are better served by feeding a clean sine wave into the distortion meter, because the output's probably going to work, but as far we're not going to be able to hear any issues with it, so we'll just use the distortion meter. Because we've got one. We just need to match our frequencies, but that's easily done. Let's do that. So, where's my mouse? I set the DAC up, so let's bring out the signal gen 48 kilohertz. Turn the escape off because we're going to overheat the CPU otherwise. Let's do both channels, 24-bit output, sine wave, 1 kilohertz. Let's do 1.1 kilohertz because that's easier to get working on the distortion meter for various reasons. It's somewhat out of cal. As far as frequency is concerned, oh, there we go, 1.1 kilohertz. And play. Do we get an input? We're getting an input of not a lot. An input of 600 millivolts. Huh. Whilst for Windows, yeah, Windows volume control is not maxed, no, 50%. Bam. That's better. We should put out like 2 volts. And we're getting 1.9 volts, which is what you usually get out of a Xonar DX. So, distortion, place your bets. Less than 0.03, but we're going through the Windows mixer. Yeah, this is shit, actually. This is absolute garbage. What am I doing wrong? Do we have the right frequency? Yeah, seems so. But we're going through the fucking Windows mix, and I know that has a tendency to cause a lot of distortion. I really want to run ACO. I so want to run ACO. Can we get ACO on the DAC? That seems we can get ACO on the DAC. Yeah, we're getting signal. Ah, that's better. That's better. Bypassing the Windows mixer fixed everything. Now we've got 0.002 something percent, but that's going to be mostly ground loop shit coming through, I'm betting. It's not going to be caused by the actual card itself. Because that power supply, that power in PC is connected to an outlet way far away from this thing, and even though we have ground separation here, it's not perfect. Yeah, you guys can't see the meter, but if I actually hard ground this, we get sporadic meter movement just from noise on the ground. So I'd say this is acceptable. Or rather, the left channel's doing good enough. Let's check the right channel. Yeah, they're both performing about the same, 0.0025-ish%. We're not clipping, are we? No. Yeah, it's good enough. It's going to be working. This is just due to the shabby test setup. So it's good enough. It's a working 2-channel output, 2-channel microphone input sound card. That's what this thing is. I don't want to put the 4362 in again in case it's just fucked. I think it might be fucked. Because I mean, if you remove a power source from a chip, I don't see why it would bloody well start drawing stupid amounts of power. It just doesn't seem right. It's a broken chip would do. So I guess we will call that. Why is this computer not? Yeah, I think I'm gonna run this. Windows update. Great. Yeah. We have a sound card which can be used, which will replace the card you're listening to now and give you guys a 40 decibel lower noise floor on my microphone, which will get rid of that horrible screeching shit you've been listening to for the last, no god, 2 hours. I was not expecting this to take 2 hours. Oh well. Thank you for watching. Bye.